Has the mystery surrounding Oumuamua finally been solved? Since its discovery 7 years ago, this enigmatic interstellar visitor has captivated scientists and sparked widespread speculation. With one question overshadowing all others, what exactly is it? While initially identified as an asteroid and later as a comet, Oumuamua defies classification due to its unique characteristics, including a surprising acceleration after passing the Sun. This unexplained burst of speed even prompted theories that Oumuamua might be an alien probe, a notion advanced by Harvard professor Avi Loeb. However, recent findings suggest there may be a more grounded explanation for Oumuamua's puzzling behavior, one that may have little to do with extraterrestrial civilizations or exotic interstellar technology. On October 19, 2017, astronomer Robert Weryk spotted an object traversing the solar system. This was a groundbreaking moment, marking the first identification of an interstellar object entering our solar neighborhood. But what initially appeared to be a breakthrough quickly spiraled into confusion. The object's properties were so unusual that even seasoned astronomers struggled to categorize it. Named Oumuamua, meaning scout or leader in Hawaiian, the visitor was initially assumed to be a comet. Comets, after all, are known to exhibit bright tails or comas when heated by the sun. But Oumuamua showed no signs of either, casting doubt on the comet hypothesis. Just a week after its discovery, scientists pivoted, reclassifying Oumuamua as an asteroid. The case seemed closed at least until Oumuamua started behaving in ways that defied known asteroid behavior, reigniting the debate. At the time of its discovery on October 19th, Oumuamua was already on its way out of the solar system. Scientists determined it had reached its closest approach to the Sun, or perihelion, on September 9th, passing within 37.6 million kilometers of our star. However, as Oumuamua moved away from the Sun, its speed began to accelerate in a way that left researchers baffled. Ordinarily, an object would slow down once it's no longer influenced by the Sun's gravitational pull. Yet Oumuamua defied this rule, moving faster than gravity alone could account for. This unexpected speed boost led experts to wonder what was causing this acceleration. One plausible explanation was outgassing, a common phenomenon in which volatile gases escape from a heated surface, often resulting in a visible tail. Outgassing has been observed in many comets, where volatile materials such as water, carbon dioxide, and ammonia escape under the heat of the Sun. However, there was a major flaw in this theory. Typically, outgassing affects an object's rotational behavior, but Oumuamua showed no sign of such a rotational change. To solve this mystery, scientists directed as many telescopes as possible toward Oumuamua. The additional observations revealed even more strange characteristics, including dramatic fluctuations in brightness. This finding suggested that Oumuamua was neither spherical nor irregularly shaped like most comets or asteroids, but rather elongated, resembling a giant cigar. However, the fluctuating brightness also didn't correspond with any known rotational pattern. Instead of rotating around a single main axis as most objects in space do, it seemed to be tumbling erratically. This chaotic motion, combined with its unusual acceleration, made it all the more difficult to classify. In yet another twist, scientists noted a complete absence of dust around Oumuamua. This was unexpected. If outgassing were the cause of its acceleration, there should have been dust or gas particles near it. The absence of such material led scientists to speculate that Oumuamua might be an unusually solid object, possibly made entirely of metal. Its exact composition remains uncertain, though. With limited observable data, scientists have had to rely on estimates for its size and structure, calculating that Oumuamua could be anywhere from 100 to 800 meters in length, depending on variables like reflectivity, density, and tensile strength. Without definitive measurements, its size remains one of many unresolved aspects of its mysterious profile. When it comes to Oumuamua's origin, the evidence is equally inconclusive. Based on its trajectory, scientists suspect it may have originated in the constellation Lyra, although they can't say for certain where it came from or how long it has been traveling. The direction and speed suggest it was expelled from its original solar system eons ago, likely as a result of gravitational interactions with a massive object, possibly a gas giant. Shortly after reclassifying Oumuamua as an asteroid, astronomers reconsidered and placed it in the category of comets once more. But this too remains a topic of contention. Some studies suggest Oumuamua could be composed of frozen hydrogen. which would explain its lack of a traditional comet tail if it sublimated in a low-temperature outgassing process, effectively making it invisible. Others propose it might be a fragment of nitrogen ice, a hypothesis that aligns with the notion of it being ejected from a planet or large body rich in nitrogen, like Pluto. The debate surrounding Oumuamua underscores the limits of our current knowledge about interstellar objects. Despite intensive research and observation, scientists still have more questions than answers. Each new theory introduces fresh questions, pushing the boundaries of what we know about the universe. With its mysterious acceleration, lack of dust or gas, and unprecedented shape and rotation, Oumuamua has forced researchers to rethink the conventional categories of comets and asteroids. Whether it is a new type of celestial body, an interstellar shard of hydrogen or nitrogen ice, or something even more exotic, Oumuamua remains one of the most intriguing discoveries of recent years. Blasted out of a Pluto-like exoplanet. Oumuamua initially appeared to be just another cosmic object passing through the solar system. Yet Harvard professor Avi Loeb proposed a groundbreaking and controversial idea: Oumuamua might not be a natural interstellar object at all, but instead an artifact from an alien civilization. Loeb, known for his bold theories in astrophysics, suggested that the object's unusual characteristics could point to its being an artificially created probe or even an alien spacecraft. Loeb is no stranger to unconventional hypotheses. He previously made headlines with his claim of finding mysterious objects at the bottom of the Pacific Ocean, which he believes could be remnants of extraterrestrial technology. More specifically, he referenced hundreds of tiny interstellar spheres he discovered within the remains of a meteorite, suggesting these could be of extraterrestrial origin. Furthermore, in September 2023, he participated via live stream in a widely publicized event where alleged alien mummies were presented in the Mexican parliament. At that event, Loeb discussed his ongoing search for extraterrestrial objects, both in Earth's atmosphere and in the solar system. Given his controversial background, it's perhaps not surprising that Loeb proposed an idea as bold as Oumuamua being an alien probe. Loeb's theory about Oumuamua centers around its unexplained acceleration and lack of dust formation, characteristics that fit an object with a large surface area and extremely thin structure. Based on these observations, Loeb speculated that Oumuamua could be a solar sail, an object propelled by radiation pressure from the sun or other stars, similar to how solar sails are designed for human-made spacecraft. Solar sails are a known propulsion technology concept, using thin materials to catch photons, creating thrust without fuel. If Oumuamua were indeed a solar sail, it would mark an extraordinary discovery, an alien object using a technology we are just beginning to explore ourselves. Instead of dismissing Loeb's radical proposal, a portion of the scientific community was open to investigating it. Astronomers at the Green Bank Observatory in West Virginia even pointed their radio telescope at Oumuamua to scan for any artificial signals, an effort to verify if it might indeed be an alien probe transmitting signals. However, a few weeks later, astronomers announced that no evidence of artificial signals had been detected. Without evidence of any technical or artificial propulsion methods, astronomers shifted focus to possible natural causes for the acceleration. Oumuamua was discovered in October 2017, but it wasn't until March 2023 that astronomers shared what they believed to be a likely solution to its mystery. The proposed explanation didn't involve alien spacecraft or solar sails, but rather a natural process. This was a disappointment to those who had hoped for evidence of extraterrestrial technology. However, the new theory left room for continued speculation, as it remains hypothetical and hasn't been directly tested on an interstellar object like Oumuamua. One challenge with Oumuamua is that it displayed characteristics never before observed in a comet. It accelerated without emitting dust, lacked the characteristic tail of a comet, and behaved unlike any known natural body. This mystery was eventually addressed by researchers Darryl Seligman and Jennifer Bergner, who posited a plausible explanation: hydrogen propulsion. They reached this conclusion after reviewing decades-old laboratory experiments from the 1970s to the 1990s, which revealed that cosmic radiation can gradually break down water ice into molecular hydrogen. This hydrogen gas could then accumulate within an object's icy structure. The theory proposes that as Oumuamua traveled through the interstellar medium, it was exposed to intense cosmic radiation that broke down water ice within its structure, creating trapped hydrogen gas. However, a significant question arose: why didn't this hydrogen escape immediately? If the hydrogen had leaked as it was formed, it wouldn't explain Oumuamua's acceleration after its closest approach to the Sun. Seligman and Bergner provided a possible solution: the hydrogen remained trapped in microscopic pores within the ice, essentially held in a kind of icy prison. Theoretical calculations supported this, suggesting that most hydrogen produced under interstellar conditions would remain trapped in a water-ice matrix until certain temperature thresholds were met.